Welcome again, my dear student. Now, in the last lecture, we have seen some basic definition. Okay, that I will revise today again because I think in last session audio is not clear. So I will revise that one. Okay, and then we will go further. Now, see here, to remember all the definitions, I have said to you that only simple diagram is sufficient for that. If you take that diagram into the consideration, obviously you will come to know each and every concept of simple machine. That is, this one is the diagram, right? Here we have applied the efforts, and here is a load that we need to lift. If I apply the efforts at this position here, then it will goes down by the y distance and it goes up by the x distance. From this diagram we are able to remember some definition. That is, first one, mechanical advantage. First one is what? Mechanical advantage, which is the ratio of load to be lifted divided by efforts applied to lift the load. Okay, and it is a unitless quantity. And second one is velocity ratio. Velocity ratio, it is the distance moved by effort divided by distance moved by the load. Okay, first thing is related to this one, that is mechanical advantage, and second is related to this one, this one, that is velocity ratio, and third thing is about this two, that is input. And input is nothing but it is the product of efforts and the distance moved by effort. Okay, and second is the output. Output is related to this one, these two things, that is, it is a load, it is a product of load to be lifted into the distance moved by the load, W into X. Okay, and now after that we have seen the efficiency. Efficiency is indicated by eta, and it is a output divided by input. Output divided by input into 100. Clear? Then output is nothing but, here is output, W into X divided by input. Here is the input, that is P into Y into 100. If I simplify this term again, then it becomes W divided by P divided by Y divided by X into 100. Means this X I have taken to the denominator. Okay, then it become W by P is nothing but mechanical advantage divided by velocity ratio into 100. It is also the another formula of the efficiency. Okay, these are the formulae we have seen in the last lecture itself. Okay, तर अशा पद्धतीने आपण सगळे फॉर्म्युले लास्टच्या व्हिडिओमध्ये आपण बघितलेले होते. तर याच्या पुढे जाऊन आपल्याला काही गोष्टी बघायच्या आहेत, त्या बघूयात. ओके, तर नेक्स्ट आपल्याला काय बघायचं आहे, तर नेक्स्ट बघायचं आहे सिंपल टास्क आहे, दॅट इज द ideal machine. Okay, that we need to obviously understand, that is ideal machine. Okay, आयडियल मशीन म्हणजे काय? आयडियल ऑब्वियसली ज्या वेळेस वर्ड हा आयडियल येतो, दॅट इज this thing is not in existence at all. Okay, but here ideal means what? The machine which exhibit the 100% efficiency is known as the ideal machine. म्हणजेच काय, या मशीनची इफिशियन्सी ही किती पाहिजे? 100% इफिशियन्सी. क्लिअर? ऑब्वियसली म्हणजेच काय, इफिशियन्सी 100%. याचा अर्थ बघा, सिंपल, इफ आय टेक द फॉर्म्युला ऑफ इफिशियन्सी, that is what? Output divided by input into 100. If the efficiency is 100%, means 100 is over here, then output divided by input into 100. 100 get cancel. If I take this input to this side, it become input is equal to the output. Input is equal to the output. Okay, means what? Whatever input we have given, it has to be converted into the output. Then and then we can say this is the ideal machine. Means the machine which have 100% efficiency is known as ideal machine. Okay, remember this one, because they will ask you the definition of the ideal machine. Also they will ask you the characteristics of ideal machine. Now what are the characteristics of ideal machine that we need to understand? Okay, as here what will exactly happen? आयडियल मशीन मध्ये इनपुट इज इक्वल टू द आउटपुट आहे. याचाच अर्थ काय? समजा आपल्याला इनपुट जास्त का द्यावं लागतं? वाय यू आर गिव्हिंग द इनपुट लार्जर? sometime because of the frictional force. Okay, friction in the machine, right? the machine मध्ये फ्रिक्शन नसतं, फ्रिक्शनल लॉसेस नसते, जे काही इनपुट आहे ते आउटपुट मध्ये कन्वर्ट झालं असतं. याचाच अर्थ जर इथं आयडियल मशीन मध्ये इनपुट इज इक्वल टू द आउटपुट आहे, याचाच अर्थ देयर इज नो फ्रिक्शनल लॉस इन द मशीन. ओके, there is no frictional loss in the machine. Understood? There is no frictional loss in the machine. That is the one another thing. This is the first, input is equal to output. Second thing, no frictional loss. No frictional loss. Understood? There is no frictional loss at all. Okay, then obviously the third thing is, we know that the efficiency is what? 100%. This is also the one of the characteristics, that is efficiency is of 100%. Okay, now one more thing we need to understand. See here, if another formula of the efficiency I will use, that is efficiency is equal to mechanical advantage divided by velocity ratio into 100. And we know that for the ideal machine efficiency is 100%, that is mechanical advantage divided by velocity ratio into 100. Now this 100 and this 100 get cancelled. Then if I take this velocity to this side, it become mechanical advantage is equal to the velocity ratio in case of obviously ideal machine, right? Like this way you need to understand the each and every concept. Okay, तर आयडियल मशीनच्या बाबतीत आपण कोणकोणत्या गोष्टी लक्षात ठेवल्यात? तर इफिशियन्सी ऑफ द मशीन इज 100%. then mechanical advantage is equal to the velocity ratio. Okay, efficiency is equal to the 100% first characteristic. Okay, next characteristics is no frictional loss, no frictional loss, and obviously third one is the mechanical advantage is equal to velocity ratio, input is equal to the output. Okay, these are the some characteristics of the ideal machine that we need to understand. Now again some phenomena regarding the ideal machine we need to understand. These are the ideal efforts, ideal efforts, ideal load, ideal load. Next one is the efforts lost in a friction, effort lost in a friction, then load lost in a friction. That thing we need to understand. Okay, that I will take into the next video.